Hi everyone and welcome back. Negative indices, let's look at this as simple as I can try to keep it. There's so many ways I explain it. Maybe different things will come out of my head as I talk about different possibilities. I have nagged my classes about if you get a negative here with an index or with an exponent, the negative means that we're going to move that n squared to the denominator. Here it is on the numerator on the top. We move it to the denominator. So I'm just going to do that first of all. No deeper meaningful understanding. If you want more understanding, just go back to previous videos on my index laws videos. So the n to the minus 2 goes to the bottom. The 5 didn't get affected though. A lot of people will move that 5 to the bottom because they sort of understand the rules, but they don't really. So the minus 2 is only affecting the n, it's not affecting the 5. So the 5 stays there. And the m to the minus 3, m to the power of minus 3, we move it from this case, the denominator to the numerator. So if I move that from the denominator to the numerator, what's happened is that negative is removed and it becomes that there. Doesn't mean that people understand the question, it's just this is how the rules work. So what I've done now is I said rewrite the following of positive indices and simplify where possible. So I've removed that from a negative to a positive, taken it from the top to the bottom. I've removed that from a negative to a positive, taken it from the bottom to the top, and you can't simplify it. There's nothing you can cancel there. So this one will have a little bit of cancelling. So again, the 4 stays on the top. Now here's the interesting part. You could use index laws and subtract these two powers. I'm not going to go there for a moment. I'm just going to show you something different that I think will work better for the people who are struggling with it. So that c with a minus 3 there with a negative 3 power is on the numerator. We want to write it on the denominator. So let's write on the denominator. So that's c to the minus 3. There it is as a c with the power of 3 on the bottom. But we already had another c on the bottom, so let's write that there as well. Now I'm going to write a multiply between them. A lot of people probably won't think of it. A lot of people could have written c to the power of 3 and c to the power of 2. And hopefully you realise between any two things there's a multiply. Let's have a look what happened here. But this already had a positive index, positive indices, so we can just leave that as the d squared. So the 4 didn't move. Again, the 4 is not affected by that. It's not affected by that. So that's basically the answer to the question, but there's one more trick to take place. So you've got the 4, you've got the d squared. Now all of us said is get rid of the positive indices and simplify where possible. So when we say simplify, we're talking about those two c's can go together. Remember, this is really c times c times c times another c times another c. So really that's c to the 5. And the shortcut is you could have just gone 3 plus a 2. Okay, so the next one, a little bit more complicated. It's got some numbers. I know some people struggling with their cancelling and their fractions. So whenever numbers are above each other in the fraction, if you can divide them by the same number, you can simplify them. So you can divide that by 5, you can divide that by 5. So I can just go 5 into 10 goes twice, and then I can go 5 into 5 goes once. Gets a bit confusing sometimes for people. In many ways, I'd probably like to leave it at last, but if you're okay with that. So that just means that we've got a 2 on the top, and we've got a 1 on the bottom, but you don't have to write that 1 on the bottom. So let's see what's left. The x to the minus 3, because of that minus again, it just means we can move it from the numerator to the denominator. Now when I say move it, the 3 stays a 3. The x stays an x and the 3 stays a 3. Then the y to the 4, that can stay on the top right here. If I wanted to, I could write at the end and leave a bit of space. And then go, okay, I've done that one, I've done that one, I've done that one. What about this one down here? The m to the minus 2 on the bottom can move to the top, and if it moves to the top, the negative becomes a positive. So all we're doing basically in this question is cancel some numbers, move the x to the bottom, move the m to the top, and then the last trick here, which people forget about, y to the 0 means 1. So if I wanted to, I could write that as times by 1. Don't have to, but I can write it there. Really the question at that point, there's no letters that are the same, so I can't cancel. So I could just write that as 2 y to the 4 m squared on x cubed. Last one here, again cancelling some fractions. So I've got this, I can go 3 into 6 goes twice. I can go 3 into 6 and 3 into 3. So if I go 3 into 6 and I write that twice, and I go I don't have to write 3 into 3 goes once, but I could have done it here. 3 into 6 goes twice, and 3 into 3 goes once. Now, they've both got y with a negative power. This is the one that really does muck people up. I'm so tempted to do different things, but I'm going to try this time and see if it works for some people's brain this way. That y to the minus 2 will go to the bottom as a y to the power of 2. So it just moves it from the numerator to the denominator. And this one will go from the denominator to the numerator. And the nice point in that is that we've gotten rid of all those negatives. So negatives are the ones that do muck people's brains up. Let's have a look what's left now. You might remember from, if I had a y on the top, I've got y times y times y times y, and this is a y times. We could write it in full. Most people probably don't need it, but I'm going to do it. So that would be 2 times y times y times y times y over y times y. So it's interesting what people do in the middle of a harder question. They forget how to do the simple things. So those y's will cross out and those y's will cross out, and all we're left with is 2y squared. And there'd be people watching this question who would say, oh, but you could just do this and you could do that. There's lots of things you could do as well. So I think it's enough of an explanation, but the other thing you could have just gone here is the 4 take the 2. When you're dividing with index laws, 4 take 2 is 2, and that's that one there.